There could be empty arrays.
Empty. Can I assume if it's not empty, the values are always valid, so there's no strings or non-numbers?
Yeah, you can assume they're well formed.
And we're guaranteed that they're sorted.
Mhm.
Okay. Sorted. Okay. So that thing mostly covers the things I want to ask. So a simple approach I'm thinking of is if I just iterate through both lists in tandem. So using two pointers and compare the value for pointer 1 with value of pointer 2. If add value that is smaller to new output array and increment its pointer. So basically I have a I pointer, j pointer, go through both lists simultaneously. If array I is smaller than or equal to array j, so I find whichever one is smaller, then I add it to the output list, and I increment only the pointer of that one. Then I keep doing the same thing. If I get to the end of one list before the other list ends, then I just add everything else that remains in the other list. How does that sound?
Mm-hmm. Yeah, makes sense.
All right, so let me say merge sorted. 1, 2, merge, merged, array, 1, join this thing, 2, array, zero. And so this one equal to let's say append I equals 1 else for 2 values greater than so j is equal to 2 value. So go through, keep incrementing, and then at the end get measure array index equals to I don't know what it's in max ij. I would be able to tell which array it is. So actually I should be able to just add the end, because if the index, if the point is at the end of the list and I try to add everything at the end, then that would just be empty. So I can just say array 1 equals to array 1 and say I all the way to the end. Array 2 remaining 2 all the way to the end. If array 1, if anything remains, just add it all to the it's array. Two remaining. I'll just do the same thing. There might be index errors, as there usually are in these cases, like off 1 by 1 errors, so I'm going to just test it, verify it's working as intended. So, merge the array. I'll write a couple test cases as well.
Good.
I'm throwing it. Let me not do that too quickly. So it's been empty. Let's do a 1, let's do a 1, 2, 3, let's go 5, 6, 7, let's go 1, 10, 20, 100, 1,000. Let's do a 0.
Sure your solution would handle either one.
Yeah. Let me try a couple of these. 2, 2, 3, 4, 5, 6, 7, 8, 1, 9. Alright, so let me go through. So 1, 2 should just be 1. And this one, array 2, 3, that's 1. Should be 1, 1, 2, 3. This one should be 4, 5, that's 1. 5, 6, 4, 5, 4, 5, 1, 5, 6, 7, 10, 20. This one should be 6, 7, 0, 1, 100, 2,000. This one should be 8, 1, 1, 0, 100. This one should be 9, 2, should be 1, 2. Alright, so let me go through all of them now. So 1, 1 is good, 1, 1, 2, 3 is good. Alright, so I have an issue with 1, it gets 5, 5, 6, 7. Alright, so this one's an issue. This one's an issue. 1, 10, 100 is good, and then 2. All right, so let's see what it's getting to. So array 9, 2, 5, array 2, 1. So it should start at 1. So let's see. If 1 and 2. If 1 is less than 2, that's true. So you add that in there. And then let me see what happens with this. So print merge array. There. Right, so merged array 2, 2. array 1, array 2. Let me count out the other ones. So it says merge arrays 2, 2, even though it's given 1, 2, 5. Okay, so probably some bug in one of these. Here. Oh, I have array 1 twice here.
Oh.
Of course, always a name error. Local variable 2. Let me replace this. The variable names. Okay, there we go. So let me uncomment the rest. Get rid of comment out these prints. Uncomment out these, and let's see. All right, so 1, 1, 1, 2, 3, 1, 5, 6, 7, 10, 0, 1, 100. Yeah, that looks good. Sorry about that random name error.
No worries. Cool. Yeah, this looks good. Could you speak to the runtime complexity of this?
Yep. So the create an array is empty. It's of 1, send all these of 1. The while loop, so I'm iterating through the array 1 and the array 2. So this would be, it stops once the pointer condition fails. So it would be O of the minimum of, let's say, n and m, where n is the size of array 1 and m is the size of array 2. So that goes to there. That's good. And then come down here for array 1 remaining. These would just be the O of, in case where, let's say we have one array of the size 1, another array of size like 100. So it's n and m. So we take everything from that 1 in the j all the way up to the n. So this would be a copy of the max of n and m, so whichever is bigger, because they have to copy all of it over. And similarly here for concatenating into this, I know in Python I can probably use a join to improve, but I don't think that would change the overall complexity. So I will say the final complexity looks like, so say O of min of n m plus O of max of n m.
For the second part, we're going to sort of generalize to instead of getting exactly 2 arrays, instead the input is going to be an array of any number of sorted arrays, and we want the same output of all of those arrays merged into a single sorted array.
Okay. So you're saying the input would be multiple arrays? And they're all sorted again? Okay. So one less optimal approach, I'm going to write at the bottom. Let's see if I can think of a couple approaches first. I have a run-in pair of pointers. Iterate through input list of arrays. A running pair of pointers to 2, let's say, arrays of arrays. So running pair of pointers to 2 arrays. Run merge sorted arrays for that pair. And then basically just take the output, take the merged array, and continue to update the second pointer, colon sorted arrays, and here repair until the end. So the time complexity on that probably won't be the best, so I'm going to see if I can think of any other approaches. Think about approach using it to keep. Let's see. Is it, because this one's a bit more complex, is it okay if I write some code, run tests, and then update my approach as I go?
Yeah, go for it.
Okay.
Yeah, I'd say you got plenty of time, so time to experiment.
Awesome. So let me say merge multiple sorted arrays. And should the input just be an array of arrays this time, or a list of arrays?
Yeah.
Right, so now again I want to, so let's say merged arrays list. If I say for I, and enumerate list of arrays. Next to this and do this. I want to append. Okay, let me see. Append. So what's at the front of each array? That's the first number and that's the smallest one. So I'm keep check out the smallest one. It's index. That's priority. Okay, so I'll give you the smallest one. So the first thing in here, what's the value? So that's 0. Index. I'll do that for now. Suppose value index. Do that. I think. Now that I think about it, I think instead I should just do stuff like heap pop and heap push instead of having some.
Yeah.
Okay.
But I think you're on the right track with
Yeah.
this approach.
All right. So if I do that, I do this. Can I check the documentation for heapify? And see how it works. Sure. Right, so import heap q, and basically if I transform this x into a heap in place, okay, that looks about right. Heapify, yeah. So if I were to run, yeah, so I say heapify, and that gives me after. This makes out of range. Right, because in cases where it's empty, that would happen. I don't address that. So just ignore it. Okay, so for one, these are a better example. Okay, 2 looks good. 1, 2, 2. This one have for 3. We do a bigger one. Should we do 5? That one has a lot. Okay, that's 2, 0, 1, 1. Okay, yep, looks like what I was expecting. So if I simplify that, so we're gonna go through it. We're gonna get. That's what we're gonna get. Okay, so let me comment these out. While it's sort of values. So I have the values in, but I just heapified. I want to get out the. What do I want to pop? I want to get the value and the index. So value index goes to as a heap up. Oh wait, that's all the way around. So I was giving this heap q. Not heap that. So those. I'm gonna add that to the output. All right, so I'll tell you what's at the top because it heapifies it, so that's at the top. So I want to say value. Let me print this to verify. Okay, yeah, so that's like what I was expecting. So I have to add that in. And how do I want to push this? Okay, let me think. What were these values? So 0, 1, 1, 1. Then I switch these. Let's in the same order. Let me see. So let me see if I have this. Which one was this? Multiple rates of 5. It's array 9, 8, 7, 6, 5, 7. Array 9, 6, 5, 7, 5, 7. Take this mouse. Probably want to compare it. What do I think? If I pump it out, I get that. So if that's index, that value, this index. Okay, so if I think if I assign some, this one has value, the index I here. Oh, let me not reuse that, let me just put 9 instead. So if this, that's minus the index, let's say, it needs to probably keep track, I think. And I'm going to open this. In every case, the value 0, put the value in. And you'll pop that out. So if you have this, you have that, you have this, take that back. Let me think this one through.
I think you're still on the right track.
Yeah. Because if I have this goes to the array, it says that value, index in the array. If I take the first one, and that index, we have that. I say this, so I is what that is in. What I want to do after I heapify set two values, I've added in there a flat so array length. Do I need the index? Yeah, I think I will need an index. I say arrays. Okay, I got that array. Then take q.
So you're pushing in three tuple, right? So
yeah.
You'll be getting something else when you heap pop.
Yeah, I'll have to add one more to that place. Index to keep track.
Mhm.
So I don't get mixed up with the names again. What's index? Index. Get that. And I want to add that value. Then I go through. I save the second index. So I get the. So if I take the first index of that, yes, I say this array index. Okay, so I get the first. Okay, so the index is for the array in those of arrays. So I have that array. Now I want to get the next value inside the array itself. So I want to say, so this gives me the index of the array in the list of arrays, and then this gives me the value of the element inside the array. So just let me rephrase this. I'm going to say q dot was it heap push. So oh yeah, that's right, because from here I want to go to the next one. So this I want to also push in here. So I'm at this first I. Then let me just say next index. Replace this. Cool. I wanted to have this on the print statements. Should be value in array. Print I. Next. Alright, so if I'm here, displace in the array. We're just keeping whatever. Look into positionals. Okay, let me see how do I want to. Oh, I guess I can just pass it as a tuple since it takes in the two. Do that, yeah, I'll do that. So what do I want in there? Because the heap push will take in the heap first, and then push something into it. Yeah. So let me move these. This should take in the order values with the heap value. Okay, so now I push that in. That's the next value in this. It's going to keep heapify it. Let me see what this gives me. That's the next out of range. If and yeah, less than of this phrase. And which index? It's for the array at the position of the first I, because I'm going through each of them. So it should be first I. This should take care of that index error, but let me verify. Okay, yeah, so that fixes that issue. Try and do it. All right, so we have one.
I think this is a pretty solid solution. But oh yeah, could you quickly speak to the runtime complexity?
Yeah, I believe a heap is log n for some of these operations. Let me think which one is which. Because if I iterate through this, this is O of the list of the arrays, let's call that n. So let me put some variables at top so it's easy to keep track. So n equals size of list, m equals size of individual array in list of arrays. Okay, so this part would be O of n. To go through this, do this, just append that in, and then heapify. What is the complexity of heapify? So if this is 10, I believe if you take, let me come back to this one. Order files, pop, I believe this is just, well, pop is just taken off from the end, so that should be O of 1. Use heap push. Because of the way the heap is structured, this one should be log n, log m. Value, yeah, m, the size of the individual one. So that's, and then going through the order of the values, another log of m. And since I'm doing the while loop, I'm going to say this is going through the whole thing, so that's O of n, I believe. And
oh, I think you have those
flipped.
Switched, yeah.
Oh yeah. And I can't remember what heapifies, but I feel like it might not be a greater complexity than the one at the bottom.
Yeah, I think it's
Yeah,
log
so it
log
should be
n.
just overall it should just be m times log of n.
You
That was
you got the
exhausting.
maximally efficient solution
Yeah.
in time.
I wish I just went with the first approach. Less stressed.
Yeah, but yeah, no, great work. So yeah, we got 5 minutes left. It's like working in like a very well-defined vertical is like it just sort of alleviates a lot of that pain of like
Yeah.
you just have a lot greater clarity that you're building the right thing for what your customers want and need. And our web apps on Django, database is Postgres. Maybe I think we use Redis for a handful of things, but and then our infrastructure is on GCP, and mobile apps or our web front. We have a web front end and native mobile apps. The web front end's in React with TypeScript. The mobile apps are both native. I think like Kotlin and Swift. Yeah, pretty simple, straightforward tech stack. Like I think the core team is 3 or 4 people, and we're getting actually somebody's joining next week, so we'll be up to 5. It's fairly typical for a small Ant org, but it's a flexible structure.
Yeah.